last question we will study in this section is this question. Consider a disk pack with 16 surfaces. How many surfaces? 6. We will write here 6 surfaces or platters. The surface is called as the platter also, is equals to 16. 128 tracks per surface. Tracks we are given as 128, and 256 sectors per track. Sectors we have provided as 256 per track. 512 bytes of data are stored in bit serial manner in a sector. So size of sector equals to 512 bytes of data. So 512 is the size of sector. Now what is we have been asked the capacity of the disk pack and the number of bits required to specify a particular sector in the disk are respectively. We have to calculate the capacity of the disk and number of bits required to specify a particular sector in a disk separately. Okay, so we'll try to write the answer. So capacity we can write as how we can calculate the capacity of the disk. So capacity is simply a number of platters into number of tracks on every platter into number of sectors on every track and into size of sector. This is simple logical question. What will be as capacity? Total number of platters, then multiplied by total number of tracks on each platter, multiplied by total number of sectors on each track, and multiplied by size of sector. Okay, so these sizes we have given. So 16 into 128 into 256 into 512. Okay. Now you can solve it by using a calculator, or we can simply write this multiplication as this: 2 raised to 4 into 2 raised to 7 into 2 raised to 8 into 2 raised to 9, isn't it? 2 raised to 4 is 16, 2 raised to 7 is 128, 2 raised to 8 is 256, and 2 raised to 9 is 512. Now multiplication will be simpler. We will add all these powers. 9 plus 8 17 plus 7 24 plus 4 28. So 2 to the power 28, or we can write this as 2 to the power 20 or 2 to the power 8 into 2 to the power 20. Okay, why we have written this? Because we know that this 2 raised to 20 is equals to how much? 1 MB. Okay, remember this if you don't know. 2 raised to 10 is equals to 1 KB, and 2 raised to 20 is equals to 1 MB. 2 raised to 30 is equals to 1 GB. Okay, so remember this: 2 raised to 10 is 1 KB, 2 raised to 20 is 1 MB, and 2 raised to 30 is 1 GB. Okay, so we are 2 raised to 20 here. So what will be a size of the disk? 2 raised to 8 MB. Okay, instead of multiplication by instead of bytes, these are these many bytes. So 2 raised to 20 bytes is equals to 1 MB. So we can write this as the 2 raised to 8 MB, or we can write this as the 2 raised to 8 means 256 megabytes. Okay, so size we have calculated. Now we will try to calculate the next question. We have been asked to find out what the disk pack and the number of bits, the capacity of the disk pack and the number of bits required to specify a particular sector. So you can calculate the number of bits to specify a particular sector by counting the number of sectors. So how many number of sectors are there in the disk? Number of sectors. So use the same formula for number of sectors: number of platters into number of tracks into number of sectors on each track. So this is equals to 2 raised to 4 into 2 raised to 7 into 2 raised to 8. 2 raised to 9 is not required because it is the size of the sector. We have to calculate how many sectors are there on the disk. So number of sectors are on the disk are equals to number of platters into number of tracks into number of sectors. So this will give you the final figure. Okay, so what is this figure? 2 raised to 4, 7, 8. So it is equals to 2 raised to 4 plus 7, 11 plus 8, 19. So how many bits will be required to represent the tracks is equals to, okay, so we will write this as formula for number of bits. Bits is equals to log to the base 2 of number of sectors. and it is equals to log to the base 2 of 2 raised to 19, and answer is log to the base 2 of 2 raised to 19 is 19. Simple. So 19 number of bits are required. Bits are required as 19, and the size or the capacity of the disk is 256 megabytes. So answer for this question is 256 megabytes is a capacity, and 19 bits are required to store the number of store the sectors, or to represent the sectors. So this is the answer. So answer is equals to 256 comma 19. This is the final answer that we have got. Okay, you might have understood this question. So thank you. If you have any doubts in the disk scheduling algorithms, you can leave your comments in the comment section. Thank you.